Thank you, by the way.
Thank you for being here. Hello, everyone. You're watching Testcontainers Live. My name is Alexa Live, and in my studio today, I have a special guest, Ricardo Ferreira, the senior developer advocate at Amazon Web Services, the infamous AW, well, the famous and popular AWS. Uh, Let me just mute my video. Uh, Ricardo is also a HashiCorp ambassador, right? The HashiCorp that produced and the creators of Terraform. Today we're going to talk about the functional tasks for Terraform providers, and I'm absolutely certain that I'm going to learn a lot. So please welcome Ricardo. Uh, how are you feeling today? How are you?
I'm good, Oleg. Thank you very much. And once again, thanks for having me here today. I'm really excited with this chance to talk about. It's. I'm going to talk about a lot of things that I like so much. Terraform, uh, task containers, right?
Right.
and
Hopefully.
and something that I started to love like recently, which is Go, because as you may know, I'm from Java world, just like you.
Right. Before joining AWS, you were actually working for Elastic and even before that for Confluent. So the creators of Apache, or like the driving power behind Apache Kafka, and then the Elasticsearch uh, technologies. So you
Yes.
have a lot of experience with various on-premise and cloud technologies, and hopefully about applications that need to work with those.
Yes. This is actually something that where I started to learn about the problems that when you have to manage infrastructure that has to be like hybrid on prem on the cloud, the type of problems that rise from this, and Terraform was one of the things that okay, all right, this is something that I should pursue a little more. So that's where I discovered the passion for this technology.
Right. At what moment did you start writing like more Go, and where did this switch occur?
I think it was when I joined Confluent. That happened in 2018, and then the trigger for me to actually know this, just to set a context, the reason why I started like working with Java, like back in the days, like before, was exactly the same reason for Go, because I was working with some middleware technologies, application servers and messaging technologies, and I decided that all right, I would never be fully understand those technologies if I don't understand how they're built in the first place in the code level, right? So that's why I got into Java,
Yeah.
right? And then when I joined Confluent, I was working with a lot of technologies that were basically written and maintained in Go. And then I followed the same mental process, which is, all right, let me take one step back and try to understand on a code level, not to, for the aim to become an expert, but to understand in a code level how things work. I think that helps you a lot in troubleshooting things. Kubernetes, for example, if you are able to see what the code is doing at code level, okay, oh, now I understand this totally not intuitive behavior that is happening in production.
No, right. The source code is always the source of truth, and if you can read it,
Yes,
you are the sort of the you can do anything.
exactly. Yeah.
Even like if you can write it, it's even better. So just
Yeah.
for the context, my personal level of familiarity with Go is more on the reading level.
Hmm.
So you will have to drive me through more complex parts of maybe today's demo. Um, but I'm fluent at staring at Go code and pretending that I understand what's happening. So so it's not going to be very bad. Uh, but let's go through what we want to do today. So we're going to talk about Terraform providers.
Yes.
Uh,
Yes. So the purpose of the session, and I hope everybody that's joined us today are like familiar with Terraform. And if you're not, that's totally fine. I think I'm going to be able to kind of conduct the session, even if you are not a Terraform user and if you are not a Go developer. That's my promise to you. You will understand, right?
Thank you.
But you can always like work behind the scenes later to kind of go deeper on this. But the purpose of the session is to show well, I have three objectives. Is to show how to implement test casing in a piece of software that is not so trivial. What I mean by trivial, like a monolith architecture written in whatever programming language. It's not simple, but it's known, right? I think that's the
Yeah.
better word than trivial. It's known. It's there's content written for it everywhere, right? Same with microservices, right? Microservice has been around for quite some time now. We can actually say that out loud, and that doesn't feel weird about it, right? Microservice is the thing these days. But when you start talking about technology that are not necessarily trivial, like a Terraform provider, it makes you feel like a bit uncomfortable about, okay, how do I implement testing in a thing that I don't fully understand how it works, how the framework works, right? Any developer has this mental process, Java developers, for instance, that, all right, ultimately, I'm going to implement a bunch of interfaces and fill the code when the callback methods or functions, if you will, right? So this is how you write the code, but you don't see the whole picture about what the framework behind the scenes are doing it to actually invoke those callbacks in the first place, right? So this is what I mean about the first objective of the session, which is trying to explain how a Terraform provider works behind the scenes, right? And I'm gonna give you like a TLDR right off the bat, which is you're gonna see that a Terraform provider is nothing more than a CRUD, right? Not sure if my accent is kind of getting into the way, but when I say CRUD, is create, read, update, delete. Right, that's it.
Right.
If you ever create a CRUD, you can
Yeah.
create a Terraform provider. I'm going to show you how this works. So this is the first objective. The second objective is obviously for this Terraform provider that I brought you today. It has the dependency of a database, the OpenSearch specifically, right? And then we're going to actually create a testing code in two versions. The first version, we're going to hard code OpenSearch. Let's call this the wrong way to do things, right? And then we're gonna test it, and luckily it's gonna work, right? And then we're going to evolve that code to implement a way better best practice, which is programmatically bring that database, or for the sake of the argument, that distributed system into the code using Testcontainers. So I'm going to show you how the Testcontainers API works for Go specifically, because that's the programming language we're going to focus today. If you are coming from Java, you probably gonna remember some of maybe the entities and the wrapper classes, wrapper structs, as you call in Go. There's no classes in general. But I think the mental model is the same. The nuances were going to be obviously the language, right? But I'm going to show all of this, so don't worry. And since we are live, feel free to ask questions. My friend Oleg is going to help me to rise up when someone makes the question. Please, Oleg, stop me because I talk too much and then I got excited doing all this stuff. So stop me, and then I will gladly answer any questions. Not sure I'm going to be able to answer the question, but I will gladly try.
Okay. No, it's good. Sounds like a good agenda. We're gonna hopefully this is short and sweet and everything works on the first try. Yep. I'm personally very interested in this because as I said, Go is less familiar for me, so I'm gonna learn things. And thank you very much for taking your time and driving us through this. So without further ado, take the reins and let's get into this.
All right. So actually, let me open Postman, because we're going to use Postman a lot, so I can explain what's happening behind the scenes in the database level. Right. That, as I mentioned before, is going to be OpenSearch. So I'm going to do this. I'm going to demo what the provider does, because ultimately, when it comes to the actual coding, we're going to mimic the behavior of what we want to test. So we're going to reproduce right now the test manually, like simulating as a user interacting with the provider, right? And then we're going to do the same thing, but programmatically, which is usually what we do in the real life. You write code to follow and mimic the steps of what the user would do, right?
Yeah.
So the Terraform provider is, I'm going to share the link of it with you in a second. But what this provider does, I'm going to see up -D. What I'm doing right now, I am spinning up a OpenSearch database manually, as you saw it, right? And this is on this Docker Compose here. So what this Terraform provider does is a kind of a database for you to catalog characters from the Marvel universe, right? So let me show you the Terraform code as an example. So this is a Terraform code, right? So for anyone who is not familiar with Terraform, this is an infrastructure as code technology, meaning you can programmatically create infrastructure using something that resembles code. Oh, Ricardo, why? Because if you can turn into code, it's testable, and you can put it in a repository, you can version control it, and more importantly, you can create pipelines of testing to deployment and production, right? So you remove the possibility of people creating things manually, which is removing the possibility of human errors, right? So in this provider that I've created, right, we're doing two things here. I call this provider built on AWS for the sake of illustration, but it could be anything. It's a string. In the end of the day, I could very well call this Oleg and the code, right? So the first part that we're going to do here when we run this code is Terraform provider creates basically two types of entities, resources and data sources. A resource is something that the code manages completely the life cycle. It creates, it reads, it deletes, and updates, right? Whereas this is a data source. A data source is basically for reading. Someone else or something else created that resource. Maybe in AWS, you went to the console and then you manually create something, and you want to pull that representation of that resource to your code. So you're going to use a data source, right? So in this resource, we're going to create a character called Daredevil, which is one of my favorite characters for the Marvel universe, by the way. And then this is his full name, his identity. He's known as the Man Without Fear, and he's a superhero, right? In the data source, we're not going to create the character Deadpool. We're going to assume that he exists. And then we're going to simply pull, or for a technical term, we're going to look up his representation using his identity, right? So
Okay.
let me run the code so we can see it, right? So the, let's see, Postman, if I query the database OpenSearch, it should have no characters catalog at this point. This is basically an internal index. OpenSearch doesn't use the concept of tables. It uses called indexes. That's how we store data in. But the point is, there's no characters on it by now. So I'm going to run into the examples folder, and I'm going to initialize the plugins. So this is interesting because every time you play with Terraform, you're going to interact with a lot of providers from different places, right? AWS, Google, Microsoft, Atomic Jar, for the sake of the argument, right? And then when you init a folder that has a Terraform code, it basically going to pull all the plugins or providers locally, right? That's what this code does, right? So now that I have the plugins installed, and we can see this, as it creates this .terraform folder locally here, so everything is already here. If we run a plan, that's the plan that we are going to execute. The plan is to create this character, and as you can see here, the plan already is telling us, oh, the data source was not loaded because the character Deadpool doesn't exist in the database. We're going to fix this problem in a minute. So what I'm going to do now is to apply this configuration minus auto approve, so I don't have to explicitly say yes. And then what just happened is that if I query the database right now, there will be an entry here called Daredevil, Matt Murdock, Man Without Fear, he's a superhero, right?
Right.
And then if I run again the plan, oh, there's no changes in the infrastructure, meaning that Terraform detects that, okay, there is no discrepancies between what is in the remote state and what I have locally. The resource has been created. There is no change. Still, is not able to load the data source. So let's fix this problem. So how we're going to fix this problem? Here, I created this JSON representation of Deadpool, basically manually create this pool. And then the script, deadpool.sh, is going to curl and going to do a post on OpenSearch to manually create that entry using that JSON payload, right?
Right.
So we're going to do everything manually here, and we're going to see that later on when we start talking about testing and test containers, everything that we're doing here on this demo is going to be done programmatically, right? So the script executed. If you go back to Postman and search for all the entries, we're going to have two characters, Daredevil, that was created by Terraform, and then Deadpool, which was created by script, right? Kind of a hybrid infrastructure creation, part by infrastructure as code, part by the, I'm going to call myself the user, right, in this scenario, right?
Mhm.
So if I run the plan again, and if I apply it, there will be no changes. But first thing as a heads up, the warning disappeared, because now both, we call this outputs, right? So in the code, let me show you again so you can understand what we're doing. There is two outputs, one to output the secret identity of Daredevil, and another to output the also known as from Deadpool. So that's what is happening here. The Daredevil secret identity is Matt Murdock, and Deadpool is also known as the Merc with a mouth, because he talks a lot, right? So what is happening here, right? So basically, we've managed to create an entry on a database, if we translate to technical terms, using the Terraform provider, right? So I mentioned this, a Terraform provider is nothing but a CRUD, right? So if I Terraform distro minus auto approve, right? I just ran the code. If I search again the database, right, there will be only Deadpool. Oh, why, Ricardo?
Right.
Why Deadpool is still there? Because remember, Deadpool was created manually, right? So it was almost like one of those situations where this can cause consistency problems, because now the code doesn't have a complete access to everything that is in the database. There's a discrepancy there, right? So that's one of the things. That's one of the beauties of Terraform. So for those of you that haven't worked with cloud implementations, you probably have heard about those stories about, oh yeah, we started using cloud, whatever cloud provider it is, but then we have some skyrocketing cloud bills these days, and we are worried that we're not going to be able to keep up with this amount of resources. It's not the only situation that creates this scenario, but one of the main causes of high cloud bills is this, what we call dangling references to resources that the infrastructure as code couldn't manage, right? In the end of the day, right? You remove everything that you thought that was created by the Terraform as code, but there was some cloud references running there, and the meter is counting, right? But you have no idea it's there, right? Because someone may be created manually, and this type of thing is complicated to track, because it's human beings being human beings, right? So, but the point I'm trying to make is that a Terraform code either creates everything for you automatically, or for the sake of today's session, it can also reference things that were created manually, right? Because this happens. Sometimes it happens, right? So I'm going to pause here. Let me check if there are any questions for us before we move on.
No questions so far. Simon, hi. Glad to have you here.
Thank you, Simon. Nice.
Right.
All right. So in this case, let's move on. So I think you got the idea about how a Terraform provider works for in a Terraform level, right? So basically the code is this. You can read this. The code is going to manage a resource, which means create, read, update, delete, or is going to simply read existing resource. That's what the code does. It's no big deal of it. This language from Terraform, we call it HCL, which stands for HashiCorp Configuration Language. That, in 2023, it's a very powerful language. It has constructs that basically mimic all the constructs that we have in major modern programming languages that go beyond, like do loopings and all of this. It's very powerful, but beyond the scope of today's session. We won't be able to cover everything that Terraform does, but it is very powerful. Now let's change gears and let me show the behind scenes of this provider in a code level. And that's where, heads up, we're going to talk about a little bit of Go. So I'm going to take my time to explain the code. And please, if raise your hands, put in a comment, or Ricardo, can I repeat? Absolutely. It will be my pleasure. All right. So let me open the code here. So as I mentioned before, a Terraform provider has two basic entities, resources and data sources, right? So let me show you the resource. That's very interesting for me to show it right now because, like I mentioned before, a Terraform provider is nothing but a CRUD, right? So this is, actually, I'm sorry, this is not the resource, it's the data source. This is the resource. So when you create a resource, you basically create an instance of this abstract entity called resource.resource. This is a package in Go, right? Package like you would have a namespace in .NET or a package in Java. And then this is the actual abstract construct, right? We call types. Everything in Go is a type, right? It can be either an interface or a struct or some more abstract types. And then you can create like any resource that you wanted, right? So the reading of here, especially if you were coming from maybe Java or C#, is that this will be your class, okay? And those functions here that has a name, and then there's a reference for the said class, those is going to be their methods, right? Technically, we call functions here in Go, but you can see them as methods, right? Any function in Go that is not associated to a type is a standalone function, right? Which is kind of a tricky to kind of create an analogy in Java because Java, all the functions belong to a class ultimately, right? But in Go, you can create a function not belonging to a type, right? So it's and these are not by coincidence because, for example, if I read the resource, this interface here has specified that every resource should have a metadata function, a schema function, a create, read, update, and guess what?
Delete.
Right. So I fulfill the promise, right? A Terraform provider is nothing more than a CRUD, right? And
some metadata. And some metadata.
And some metadata, exactly. And ultimately, what of those are callback methods or callback functions. It is up to you to just derive a new type and fill the callbacks with some code, right? So the schema is ultimately one of the most important ones because, as you can see here, our job is to provide a schema request and schema response. And then the schema does, as the name implies, is to design what's going to be the fields of your resource. So if we go back to the Terraform provider, where's the code? Here we go. Example. So full name, identity, no S, type, those are fields, right? Just like you would do columns in a table in a database, right? So we've defined those fields here. And we define the type, if they are required, mandatory, if they have defaults. So basically, you are describing your field. And then you have the configure, which is basically, this is how I actually retrieve the connection with the my backend, right? Mm-hmm. Now, typically, and this is like kind of a line of a best practice here, typically, a Terraform provider communicates with an API, right? Or some SDK that exposes an API. And here, for illustration purposes, I'm interacting directly with the database. Some may consider this not necessarily a bad practice, but a good practice, and I agree with them ultimately. But since this code is for illustration purposes, it's fine for you to actually interact with the client of your backend here directly, right? But just FYI, usually here you would set up a connection with an API, right? Or SDK, whatever SDK is. For example, if you play with the AWS provider and you use Terraform to create an S3 bucket, for example, what that provider is doing is interacting with the AWS SDK for Go, which ultimately is interacting with the AWS REST APIs for S3. So there's a hierarchy that you are invoking here. And then create. I'm going to create a character. I'm fulfilling the payload. As you can see here, I'm basically executing a REST API request because OpenSearch is all about this. It exposes a REST API. You put, post, delete. That's it. That's not much of it. The read is the same thing. Yeah, I'm going to do a get request, giving the ID that I've already have. And I think you got the drill, right? The update's going to update the existing fields. Let's start talking about the testing that we have right now. I think that's the whole point that we're here. Let me show you. I have three tasks already implemented. The first one is the resource. So the whole code of the resource is here. It's filled. And then for the data source, we're going to do together, right? Because this is what I'm going to show you how it looks like. But just walk you through and how the testing works. So basically, we create a backend container here that right now is doing something really dummy and hard-coded, which is I'm creating a backend container, which is this type that has an address. And then I'm hard-coding the backend address default, which points to this, localhost 9200. So yes, this is a very bad practice. Please don't do this in your actual testing scenarios. We're here exactly to show that you should do authorize, right? But this is a good way for you to start your coding test, right? Start with this and make sure it works, right? So what I'm going to do now is actually run this test so you can see our backend is running, right? So
yes,
OpenSearch is still running. Okay, so I'm going to run the test, make test. I'm going to explain what this make does in a minute, but just make sure everything is working. So all tasks pass. We have 3 tests, one for the data source, one for the actual resource, and then I have a test this is for the provider, right? I basically test if the provider can validate the address for OpenSearch, and also if they can establish connectivity, right? Because if there's no connectivity, there's no point to actually, all the other tests will fail. Basically, that's the criteria. Now, so with that said, let me show you what this test is doing. Actually, I promised that I would explain what make test does. So make is the make file.
It ran go test, right?
Exactly. It's do a go test. So basically, when I make test, I'm executing this. And that is go test, as you can see here, right? I'm specifying a timeout or 5 minutes for obvious reasons. Since I'm dealing with cloud resources, there's only so much I can wait for the test. This is the folder where the go test is going to find the test file, which is built on AWS right here. And then there's a very interesting thing. That's a peculiarity of Terraform. Always export this environment variable with something on it. It doesn't have to be one. It can be anything. It's a string, right? This informs Terraform or the Go Terraform code that you are not intentionally want to create things, right? And Terraform will understand and say, oh, okay, so if there's something on the cloud provider that if I create is going to bill and according to money, is going to say, okay, so I have to create only a local representation of that resource, not in the cloud provider, right? So this is very useful because how many times you're going to run your tests in a daily basis or an hourly basis if you have a code pipeline, right? So you're going to create a lot of resource. But this is important. And this is basically me saying that I don't want to cache successful results of testing. It means that even if a test already succeeds, I am going to rerun all over again because I don't trust the code. I always believe that the code is going to try to trick me, and then I want to run everything from scratch. From the same author of, if you don't compile from the source code, I don't trust.
No, but this is more tests fail for random reasons, and you have to rerun them. And there is a little bit of the same problem with Gradle. Sometimes I forget, and then I run it, and it caches the results, and I want to run it again, and it surprises me. So like this is good practice. Good practice.
Yep. It leads you to think that everything is working when it's not, right?
Yeah.
So all right. So let me walk you through the code so we can start implementing the data source. So basically how the testing works, let me make some space here so we can understand. Basically, I'm creating a backend container that, as I shown before, is hard-coded, so it's a bad practice. We're going to fix this in a minute. I'm going to create a character, right? And this is where I'm going to programmatically write some Terraform code, right? that intends to create a resource. And here I'm basically doing some substitutions. I'm substituting this mark here with the actual backend address, right? Which still is hard coded, so it kind of doesn't make sense yet, right? And then I'm forcing some changes, which is by default, I'm going to say that the Daredevil is known as something, and then I'm going to change to something else to force an update, right? So ultimately, I'm writing this via code. I am writing, where is the examples folder? Via code, I'm writing this, okay? So, which is a string, as you can see here. And then here's how you actually do the testing, right? You specify which is the resource name, and then the resource has this function, callback function called test, right? Which basically you provide your pointer to a test. So tests in Go are basically a function that start with test in uppercase, right? And then you have this reference of this testing pointer, right? Which gives you access to a bunch of things, but ultimately you're going to use this to raise errors, throw any you want to propagate to the upper layers, anything that you want to communicate to other functions, and also if you want to communicate if a test failed or passed, right? So you're going to use this T over here. It's been given you by reference as a pointer, right? So this is the pointer and Go.
Right. So it's just like we have a pointer to the context, so we can interact with the testing context, so to speak.
Exactly. So what I'm doing is on the test, I'm providing the testing pointer for them, and then I'm creating my case, which is, what is my test case? My test case is comprised by one or multiple steps, right? You can either create a one-on-one relationship by test case and steps, right? This is kind of considered a best practice in the Terraform world. But if you're dealing with a limited scope of something, maybe a microservice, you can actually create steps of them. Basically, the main difference is some resources will be reused. You don't have to instantiate all over again from scratch. So my tasks will be basically the create and reading test. So I check here if this is my check, right? Everything is a callback in here. So the check is check if the resource name, this full name matches the new name. So the code is going to raise either yes or no to this, right? No big deal. And then it's going to verify if some attributes has been set, because the attribute ID and last updated, they are automatically filled or populated every time you run the Terraform code. So basically, it's going to test if this is not different than nil, right? I always had the tendency to say null because no Java thing, but in Go it's nil, so it's a thing. And then I'm going to provide some other testings as well, which is kind of a update and read testing. So I am going to verify if now the new name matches with the former name, and so forth, so on. So as you can see here, basically, you have to create your test case and then create a series of steps of what you want to create. And the SDK from Terraform is quite powerful for everything that you want to check, which is if an attribute change, if the attribute length equals to something, if the attribute has been updated in the last timestamp, time FYI, things like this. So it provides you everything you need for this. But as you can see here, this is the resource. Let's talk about the data source. The data source is nothing. That's why it's passing right off the bat when we run the test. Let's do this step by step so we can understand how it goes. I think the first thing we can do here is do this, which is grab the context, right? A context is how do you pass things around through your code, right? This is a kind of a Go thing, right? In Java and a JVM, we can reference some global states in the JVM very easily via code. But in here in Go, everything is more explicit. So if you want to package from all the other places to actually know something from your code, you can give to them the context, right? So it's like a ball that's being kicked around all over the place.
Yeah.
Right? So we create a container, which is right now still manually. We're going to get there. And then we're going to actually create a character. So we need to instantiate a new character by code, right? So just for
Right.
you to know, comic character is what we call a struct, a class without methods, if you will, right? Is a struct, right? And then there's some errors because those variables are not being used yet. So don't mind them. That's what's happening here. So what we are going to do, we need to create this character manually. Remember when we were testing the Deadpool data source, and the Deadpool, we had to manually run a script to create it?
Right.
So this is what we're going to do now. We're going to manually create a character because remember, the data source doesn't create anything. It basically look up. So for the testing logic, we're going to manually create, and then thereafter, we're going to look up the code. And this is going to be the testing criteria. Did it actually look up? Because if it did, the data source worked, right? And then there's no create character function. Let's create it right now. So I actually have here something kind of predefined. So now this function called this, and then we're going to provide the context, the characters, the reference, the pointer to the character, and the backend container to do what it does, right?
Right.
And then here is basically OpenSearch client code for Go. So we're going to instantiate a backend client or for OpenSearch. And then basically you have to provide a backend address, which is coming from this container here, which is still hard-coded. We're going to change that, right? And then once we have this, we need to serialize the JSON, not the JSON, sorry. The character that we're passing as a reference here, we're going to serialize this into JSON, right? Because this is what OpenSearch expects, JSON. And then once we have this serialized into JSON, which is going to be the body of our request. Remember, everything in OpenSearch is a REST API call, right?
Right.
We're going to index this request, passing the body, which is now in JSON, right? And then we're going to simply run the execution of this, which is basically pick up the index request we created with the new body, and then we're going to execute or do, right? Backend client, here's the context, here's the request. Either we're going to have an error or not. So that's why we're in here, and we're always testing if there's some errors coming out of the function calls. Not a very interesting thing to do in Go. I'm going to admit that. This is not a big fan of Go. I think programming language like Java has more interesting construct to deal with this whole like how to handle exception and errors than this. But I gotta hand it to Go. Like this is one way for us to have more control of what you're doing. That's one of the things that I like it in Go. You can clearly see what you're doing, and you are less dependent of the runtime magic, if you will. You know, like the throws clause in Java, for example, or throw to new exception. So it's a trade-off. You're gonna trade simplicity with control. So that's basically the difference, right? All right. So back to what we're doing. We create a character manually, and then we're going to create the Terraform configuration. Now, at this point, we should have the character created in the database. So now we can start the testing, right? But what's going to be your test? Our test, we're going to point the provider to the address, and we're going to do the lookup. Given the identity, let's look up. So let's do some substitutions here because we need to replace the address and the tags here. We're going to name the data source, and here is our test. Let me put this here below. All right. So what's going to be our test? There's going to be only one step, and we're going to check. It's going to be an aggregate test function. It's going to check if the full name, known as, and type has been filled with data.
Right.
Which is what I called before a lookup, right? So Ricardo, why you are checking if it's been filled by data? Because if you look to the data source code, this is what the code does. This is the actual code of the data source, right? So this is what the development team wrote that I am testing, right? So what the development team wrote was giving the ID of something, which is this, I create a search body, and then I'm going to execute a search in OpenSearch. And then if there are any responses coming from OpenSearch, I'm going to grab the first hit on the result, and look at here. I'm going to fill with data, right?
Yeah.
Because otherwise it's going to be new, empty, right? So we are creating the inverted logic in the testing, right? So we are testing if this is true. It was filled with data, right? So if it was, then the data source is working, right? Now that we have this code, let's run one more time and see if we didn't break anything, right? So make test. So data source pass, so we're good. The resource, we didn't change the test, so everything is running as expected.
Can we break a test here? Never trust a test you haven't seen failing. So let's break a test.
Let's break a test. So I think the best way to break a test is doing this: Docker compose down.
No. You just like check, like do the full name plus like something.
Something else, for example.
Yeah. So they're just, I mean, you're stopping the container already. It's fine. We'll break it later.
We'll break it later. Yeah. I mean, we can actually test this while Docker contain up, and then we can do this. Let's do here this test that checks if the check resource attribute set. Okay, here we go. Yeah, it's still running. Okay, good. So we can test this. Data source name, and then we can check character full name. We can replace to don't do this. Okay, we can put this, or we can put something else, like something else. This is obviously going to break, right? So let's run again. So we're testing
because the thing that the Terraform provider finds in the database, the full name field is not something else, right? So
exactly, yeah. No, actually, it's going to check if it is something else.
Yeah,
which won't, right?
Yeah, and then it will fail.
Yeah. So make test. Perfect. Yep, it failed.
Yeah,
it was expecting that pool, and then it got something else, right? So. And this is a very good exercise, because I agree with you. Like, don't trust anything that's like passed like from the first time. That's can we call this introducing chaos to your testing? Is this like a thing? This is a good name?
I think other practices take that name, but I think it's just never trust a test you haven't seen failing. It's a good code name for this.
Yeah.
Because you never like, it could have been like you have the test suite, right? Like, and it passes. It could be that the tests are empty, or it could be that the those checks are not like comprehensive, right? Like it's not the full checks, right? Or sometimes you just somebody else, maybe you 6 months ago, when you were a different person, you wrote tests differently that don't actually test anything. Then failing tests are good, because then you actually know that they do check something.
Yep.
Okay, so now we have the test, right? So now we can do the second step, is make them not depend on our local environment, and have the dynamic environment creation with test containers.
Yes, let's do this. And I think that's a good step for us to actually Docker compose down our OpenSearch, because we're going to actually, that's the point, we're going to bring that dependency, right, programmatically using task containers, right? So what this means, if we run the code right now, it won't work, because now we're doing a bad practice, which is assuming that the backend is up and running, right, which is no longer the case. So obviously the test is going to break. So let's fix this, right? So let's do this where it actually matters. So all the containers are created on this create backend container function that, as I mentioned before, is hard coding to basically return the back address default, right? So let's change this. So what we're going to do this is, let me remove this for a second. This is hard code. We can start with a container request, right? And then we're going to do the task containers, and then we're going to create a container request. This is basically how you would start many things with your code. So first thing for the container request is, what is the image, right? So just FYI, you are seeing here that the code is giving suggestions, right, as I type, right? And the reasons for this is because I have a plugin in my Visual Studio Code called Code Whisperer. So this is what the IDE is doing. So most likely, if you do this by your own, you won't have this kind of a suggestions going on. So this is called Code Whisperer, right? So that's a plugin that you can install. So back to what I was saying, what we are going to create here is a representation of this. We're going to create a container that has this information, right? So it has an image, container name, host name. We won't need host name, but anyway. And then we're going to set the environment to customize the container, right? So let's keep going. The image is this. The name of the container is going to be OpenSearch, right? And then the exposed ports, exposed ports. So it's going to be a string, and then we can actually steal this here. So the default port we're going to call 9200, right? But technically, the task container, the port that's actually going to be created, we don't know. We're going to do a mapping later, right? But ultimately, that's what we want, right? And then we're going to set the environment. So the environment is a map, right, where the key is a string and then the values are strings as well. So we are going to fill this with cluster name. Actually, let me do this to speed up things.
Yes. While you're doing this, so this is I can provide some context here.
Yeah,
right.
Definitely.
What we're using here is a test containers for Golang API, directly implementing the container request, implementing the waiting strategy, which will tell us when the service in the container is running, and we can proceed with the test, because, well, it's not enough to start the container, right? We also want OpenSearch to start and be ready to serve our queries. So we need to wait for, in this case, we're waiting for a log line in the container logs that would say, like, node started, all good. We provide some configuration, for example, limiting the memory and providing the cluster names and everything. There is a possibility, even in test containers Go, to what we have the ecosystem of modules, which are not Go modules, but they're sort of like plugins for test containers Go implementation, where this configuration for the particular technologies are hidden from the end user. You can override that, but you can also just say, give me an OpenSearch container, run my OpenSearch container, and then you don't have to know how to run an OpenSearch cluster in a single node Docker container. So there are a number of those, and that number of those modules are growing. So if you're interested in a particular technology like OpenSearch, please consider talking to us, raise an issue. If you can contribute the actual module definition, we have a previous video about how to do that. And that would be great to see more and more of those modules for test containers available out of the box for test containers for Go, just as much as we have them, for example, in other ecosystems like Java or .NET.
Yep. And even for Go, I think I've worked with some, which is there's one for Kafka, Redis, I think MySQL. I think those work pretty good.
Like yes. We have also. Well, I think we have I think I'm looking at the web page that shows the list. We have the HashiCorp Vault. We have Red Panda. We have Redis, Apache Pulsar, Postgres, Neo4j, MySQL, local stack. And which might be very, very interesting specifically for the Go community, we have the K3s module, which will spin up the K3s Kubernetes cluster in a Docker container. So if you're doing any sort of like operator development, or if your code needs a Kubernetes cluster to run with, that could be very handy.
Yep. And one interesting trick about Go, and that's something that I like it in Go. You see that this is not acknowledging the uses of this task container package, right? And if you go here to the import clause, you're going to see this, oh, no, you don't have this dependence already included. So that's a very magical thing in Go that you can run, which is the command go mod tidy. So it downloads all the dependencies and fix it up everything for you. That's one of the things that are really, really interesting, the dependency management in terms of libraries in Go. So now everything is fixed, and then the only error we have is that this variable is not being used, which is expected, right? Because it's not being used anywhere anyway. So the interesting thing to know about this programming here that we're doing here is that we're only created a container request. So this is not the actual container, right? The actual container is going to be created now. What I mean by actual container, the actual instance of the container, right? So we're passing by a container request, which is this little one over here. And then we can pass flags like, oh, not only I want you to create a container, but I want you to start it, right? And if for some reason you already have a container called OpenSearch already running, I want you to reuse it, right? Which is very, very tricky. So you don't have to kind of recreate the container all over again, which has pros and cons, right? If you are really concerned about data consistency, I would recommend like turn this to false, because it forces the task to rely on a very clean a clean instance of the container. But anyway, the best advice is do what your codes expect you to do, right? The amount of robustness that your code expects, right? And then we're going to finally do what we're supposed to do. Now the container has been created, and in a minute I'm going to run this and I'm going to see this happening. We're going to actually, all right, from the container created, we're going to retrieve the host name, right? And then we're going to retrieve the mapped port. Oh, Ricardo, what is this? So this is, although we asked that the container internally has the 9200 port, but the port that's going to be exposed to the outside world is what we call the mapped port, right? This is how your code is going to connect with that container, right? So the last thing we need to do, and this is kind of basically a Go best practice, we need to include, where is my types? Okay, I need to include this container here in my struct over here. Container, the type, backend container, task containers, which is this. Where's my reference to the container? Here. Yeah, it's a container. That's the type name. That's containers. Is this? I'm doing right. I think it's this. Yeah. So why I'm doing this, why this is a best practice, basically in the struct that I'm creating, I'm holding also the reference to the test container. So the life cycle of this container will be dictated by this variable over here, right? So it's kind of like a tip for the runtime garbage collector. It's you making the code more efficient. So we have everything in place. Let's try this theory right now. And for this, I'm going to open this tab, which is my Docker tab. So you can see all the containers running over here, right? I'm going to open up my terminal. So there's no containers, right?
Yeah.
So let's see the magic. So let's run the test one over again. So now what the code does is to create the container. As you can see here, it created, right? And then once the clause that waits for a specific log reaches, so it runs the test all over the container. And right almost immediately, it removes the container up and running in a matter of seconds. Here you go, yay! All right, good.
Right.
This is the Ripper, right? Is the
Yeah.
right name Ripper?
Yeah. It's a resource. Oh god. So the code name for this is Rook, which is the resource reaper. But yeah, you can also manage the lifecycle yourself, and you can close the containers if you want. There is an API for that. But if you don't, the tests that the containers that outlive your tests will be cleaned up, because we really want to have the clean slate. And then next time you run your tests, we don't want them to connect to like some random containers that were still hanging from you running tests yesterday.
Gotcha.
Because especially somewhere on CI, if you're using like beefy machines that you share across the team with other people, and they run your CI jobs, and then suddenly there is some resource which is from your test gets into some other's test, like pipeline job, that could be an issue that you're going to debug for a number of hours. And if it's you, it's okay. But like if it's somebody else who's going to debug, they will come to you to have words with you about the situation. So clean up is very, very important for reproducibility of the tests. Which is
consistency, great. Right? It's to ensure consistency. Speaking about consistency, Oleg, I'm gonna try something here that I'm not sure if it's gonna work, and if not, that's the ultimate proof that we're doing this alive. But I'm gonna do this. I'm going to stop my Docker. Here's what we're gonna do. I'm going to stop my Docker engine locally. I am going to switch this testing execution to the Testcontainers cloud using Testcontainer desktop. As you can see here, I'm running, right? So everything is running locally. So I'm going to do this. I'm going to switch to Testcontainers cloud.
Right, perfect.
And to prove that I'm not cheating, right, I'm going to do this. I am actually going to quit my Docker desktop, right? So there's no Docker engine.
Perfect.
Ricardo, can you prove to me? Yeah, Docker images. I can't connect with the demo anymore.
Right. Okay.
So let's open the dashboard, and I'm gonna move this dashboard here to this window so we can see it. So this is the Testcontainers cloud. So what needs to happen is this: without me changing a single line of code, I'm gonna simply rerun my test. And Testcontainer, don't ask me how, because this is, to me, sounds like voodoo magic. Probably Oleg know how this works, but it's going to simply spin up a container in the cloud transparently for you. It's going to make your test point to that container, execute the test, and get rid of this container immediately, right? So let's test this.
Technically, it's going to provision you an isolated VM, which will run Docker daemon and will do the connection. So you can run multiple containers. Or if you run tests in succession, you will still be connected to the same VM. You will. It doesn't work on the container level, so it works on sort of the VM level there. But yeah, it will transparently configure your local station, so the Testcontainers test can connect to that isolated VM, and the containers are not running locally, saving you the resources and make it absolutely consistent across all the environments, like your CI, your Windows machine, your Mac machine, your I don't know, Linux environments, and so on. So
exactly, yeah. Let's test this theory, and then I have a comment to make. So let's see if this works. Like make test. So
I hope this works. This is non-scripted.
Yes, this is totally like we decided to do this like very recently, so I'm not sure it's gonna work. If though,
no, it should work. Look, it's already it worked sort of. It's currently waiting for the container, and this is the fresh lease. So the Docker cache on the VM that you got doesn't have the OpenSearch container yet, so it needs to pull the image. It should take a few seconds because pulling from a
It's the
cloud
first
instance
time,
to
right?
cloud instance is very, very fast. The next test run will use the Docker cache on that VM naturally, so it will be faster. You will not have to wait for this. But you can see that
Is this? Is this
immediately
the one
here.
here?
Yeah, I think this is the session. The container is started and is being run. And if you look at the tests, I think very soon it's
Oh,
supposed
here
to
we
start
go.
running tests.
So
Right.
cool.
So if you rerun it again, then it will not. It will be more.
Won't take that long.
Yeah, it won't take that long, and it will be more sort of like when you run the tests normally. It still needs to start the OpenSearch container anew, but hopefully it will not pull.
Everything from scratch. Yeah. Oh, here we
Yeah.
go.
So
Way
you can see
faster.
it's way faster.
Yeah. And I like it when I tested this the first time, because you can see in a session, you have this concept of session here, and then you can see in a per instance basis this information here, which is when the container was created and when it died, and then you can calculate like for how long it was used, which is, this is pretty cool.
Yes, and it's also like this is very helpful, this dashboard, for two reasons. One, you can see now you're currently using all users. So if you have a team with multiple people using, you can see which images you're testing with. So for example, you can standardize that your test should use OpenSearch 290. And then if something like 280 pops up, you could be like, in production we use 2.9, so let's test on the same infrastructure as in production. And then so that is one thing which is very visible. And the second one, if you run a complex test suite, you will see here the containers popping up, spinning down, and then you can see maybe some improvements to, do you need to spin up so many containers? Do you need to maybe consolidate the test somehow? Or maybe if you are consuming all of the resources and you bottleneck on how many containers you're running at once, like for example, if you run your test in parallel, you can see, and then you can split it and sort of parallelize on the process level, because in the cloud it's very easy to scale horizontally, right? Like you could run this Go test in parallel, and the different processes would sort of get, every one of them will get the isolated VM in the cloud, because the resources there scale to almost infinity naturally, and then and then your test can run in parallel like 3-4 times faster than normally your pipeline would run.
Nice.
So this is very useful.
No, super. I remember that before I was being a Mac user, I used to run Fedora in my laptop. Like I use it for many years, and obviously, like you can have Docker and Fedora, and we all know that works. But from time to time, every time we would update some dependencies on Fedora or something like this, my Docker stall would fail for many reasons. Like the Docker mount would fail. So I would always have lots of problem dealing with Docker locally. But with this, I could completely get rid of my Docker install, focus on my job, which is writing testing code, and then kind of directly everything to Testcontainers. So I think that's a very good win for if you don't want the hassle to dealing with dependencies that are not part of your job, right? Your job is not to contain Docker, right? Your job is writing tests, right?
Yes, absolutely. And you can also enable this Testcontainers Cloud for CI, right? So if you want absolutely the same Docker environment locally and then CI, and then you can reproduce the issues the same way. So you don't have subtle differences in some people running like Docker in a Windows Linux subsystem, and then in CI you run Docker in container, and then something is different there, and then so cloud removes all those issues.
Nice.
Right. So this is very cool.
Yes. I think we're on time, or we should.
Yes, we are on time. So this is what we did. Let me try to summarize what I learned
Go ahead.
Today. Right. We looked at a sample Terraform provider for Marvel superheroes. We looked at the Go code that implements that. We learned a little bit what the Terraform provider is, and then we wrote some test code for testing this create, read, update, delete functionality that provider gives us for the resources, and wrote the Datasource tests from scratch, connected them to the OpenSearch container, and looked at how you can create ephemeral infrastructure very easily with Testcontainers for Go.
Yes, that's all about right. And switch it from deploying locally to Testcontainers Cloud.
To Testcontainers Cloud. We switched it and looked at the Testcontainers Cloud, looked at the Testcontainers desktop app that can enable those things very, very easily for you. So if you're using Testcontainers, check out the app. It's very cool. So try it. And you have a bunch of resources that we can share, right? Like if you're watching this on YouTube and not live, and you don't have the ability to ask questions, then please do check out the repository. Let me put it in the chat as well.
Yeah, I've sent you on the private chat, so if you could share with them, thank you.
And if you would like to connect with Ricardo, you are welcome to check out the referray.com website and any of the social networks where you go for this with the same handle, right?
Referray, yeah.
Referray dot. No, there is no dots, right? It's Referray on Twitter, LinkedIn, and so on.
Yep.
Perfect. Thank you very much. It was a pleasure to have you. I learned a lot. I feel more confident in that I could write some tests with Go, and this was very, very good. So
thank you.
Please, if you're watching this later, subscribe to the channel, drop us a message, leave a comment if this is useful, and then go follow Ricardo on social. If you have questions, ask him. I'm sure he'd be happy to chat about anything, about Terraform, about AWS, about Go code. And thank you very much once again for joining us. It was a pleasure.
Yes, same here. And thanks everybody for joining today. I hope you have a good one. And Oleg, my friend, you're the man.
Thank you. Right. Happy testing. Bye.
Bye.